Hey folks, I'm Mr. Hartzler here for Hartzler University. I want to talk to you about coterminal angles and reference angles. Let's get some of the definitions out of the way. Alright, so when finding the measure of an angle in standard position, I first have to know what all of these words are. So my initial side is always this yellow, orangey, what did I call it? Pumpkin spice. That's what I've been telling my kids. This pumpkin spice color, that's always my initial side, unless specified otherwise. My terminal side is where I end. And then my standard angle is that one there. Whichever comes from my initial side, however this thing ran around to get to this other side, that is my my standard position, my standard angle. It's important to note here too, if I have this being my initial side and I come up to whatever that place might be, that is a positive angle. If, however, I start at my initial side and I go down, so I'm going clockwise in this case, that gets me a negative angle. So whatever that number should be, but it just happens to be positive or negative depending on which way I'm rotating around my circle. Counterclockwise is positive, clockwise is negative. So here, I have that coordinate point. They told me find the angle in standard position, but they only gave me this and drew this little picture. But I know more about this. Let's turn this thing into a triangle. So I'm going to take that dot and I'm going to come straight down. I always want to come straight down to wherever my x-axis is, or sometimes up, I guess, if I'm in the third and fourth quadrant. But whichever quadrant I'm in, go to your nearest x-axis and draw a line. That now becomes a right triangle. Awesome, right? This will lead in to our unit circle stuff. So I have that right triangle. Well, what are my legs of this? Because I have a coordinate point, but what does that really mean in terms of a triangle? Well, if I'm at -4 on my x, that means I went left 4. So this is a -4. So that means this side is 4. I went up to 4, square root of 3, whatever that number might be. And because of that, I know my height. My this leg over here is 4 square root of 3. I'm not even given my hypotenuse. I could find it if I want to, but I don't necessarily need to. Now, I cheated for you a little bit. I put this triangle over here. This one is our 30, 60, 90. Remember, we also have our 45, 45, 90. Where these two sides are the same. But looking at that square root of 3, I probably have to deal with my 30, 60, 90 because my 45, 45, 90 doesn't have a square root of 3 in it. So then, opposite of my angle, right? This is my new angle I'm caring about here because that's the one on the side of the triangle. Opposite of that has a square root of 3. So what opposite side has a square root of 3 on it? 60. Opposite of 60 is a square root of 3. Okay. What about adjacent to 60 is a 1. Okay, well, let's see the comparisons there. Let's scale up this 30, 60, 90 triangle by 4 all the way around it. When I have 4 square root of 3 and 4 times 1, which is just 4. So let's check this again. Opposite is 60, 4 square root of 3, check. Adjacent to 60, 4, check. So my angle must be that 60. This is why it is incredibly important to know and be able to draw quickly the special right triangle. So the 45, 45, 90 and the 30, 60, 90 triangle. I think it can be very helpful when finding out ones like this. If I only had square roots of 2's in there, I would probably be drawing my 45, 45, 90. Let's go on to our next example. All right, so not necessarily an example, but this is important. Coterminal angles. Co meaning like, well, if I had co-presidents, then both people would be equally president, right? Coterminal angles are the same. Co are like both, terminal, ending, angles. So like they're both ending at the same spot. So positive angles. My positive angle measure, I go up, I hit this, that's 120. If I took that same initial side and went down and around, well, that's -240, but notice that's in the exact same location. What if I went around positive? So I'm looking at the far right now. I went around one full rotation, that takes me to here, but then I went another 120 degrees. Well, same location, right? All of these are exactly the same. So 120 degrees is exactly the same location as a -240 degrees, which is exactly the same location as a 480 degrees. It's kind of neat that way, right? And I can add as many rotations as I want. I can add a whole nother rotation to this. Add 360 to 45. Boom, I got my next angle. Let's write it out. 480, 360. That's a 4, carry my 1. That's 840. An 840 would be another one. And I could also subtract another 360. So it would be the same as a -600, right? Yeah, that's awesome, isn't it? And this isn't always helpful, but sometimes it is. Sometimes you'll be given a large angle and you need to find out more what that thing actually looks like. And it's helpful to then reduce it down, because that's usually the problem. I'm given something, where's my cursor at? I'm given something like the 480, and I've got to go down to the 120. Usually that one's the more helpful one. All right, so coterminal angles means they share the same terminal side or the ending side. Wherever they end, they all end the same place. Let's keep going and check out some more examples. All right, so reference angles. The acute angle formed between the terminal side of the angle and the x-axis. So wherever I'm at, I need to take that line straight down to my x-axis or straight up to my x-axis. I want to go to my nearest x-axis, and that little thing, that little angle there, that's acute, right? It's acute, it's little. That one is considered my reference angle. My reference angle is going to be what triangle would I reference if I drew a triangle in there? And I always, again, I do that down to my x-axis, my nearest one. All right, so the reference angle of this one, well, all the way around to this line would be 180. So I've gone 135. How much is left? So 180 minus 135 gets me 45. Nice. So my reference angle is 45 degrees. What quadrant am I in? Well, look at this little table-ish thing to the right. Quadrant 1 is where I start, and then 2, and then 3, and then 4. I told you a second ago, counterclockwise is how I count positive angles. That's how I count quadrants too. My first quadrant is positive, still positive. I keep going around, and now when I'm in fourth quadrant, I've hit 360 right there when I come all the way around. This side is positive angles, and if I'm going this way around, it's a negative angle. That is important to note. That will come about frequently, and that is a common way students miss problems. So which quadrant am I in? 1, and then 2. Awesome, I'm in quadrant 2. We use Roman numerals for some reason. And then 3 vertical lines for third, and then 1, and then a 5, or sorry, an I and then a V to get me 4, right? Because V means 5, and I've got a 1 or an L or I, sorry, before that. So that's 1 short of 5. Fun facts for you. Let's keep going, and let's do some examples like this. So I'm here. I need to find reference angles. So my reference angles, that's the one if I go to my nearest x-axis. So in this case, it's this one. I'll assume it's a pretty line. It's a straight 90-degree angle there. All right, so if I came around 210, remember, over to here, this is to 180. Well, I went how much past that? 30 degrees. So I have a 30-degree reference angle. Which quadrant am I in? Right there. Where's that at? Third quadrant. Third quad. All right, now I'm over here at this one. 75. I'm going to take that straight down to draw a 90-degree angle. I go up. That's actually 75 right there. So 75 degrees. What quadrant am I in? 1, or I. And then 315. Well, I've gone all the way around to here. So I need to draw my line straight up to my nearest x-axis. Well, I need this middle missing piece right here. 360 is all the way around. How short am I of 360? 45. I'm 45 degrees short of a 360, so that's what makes up this little chunk inside this triangle. And I am in quad 4. Let's go on and check out some more examples. Now I'm finding coterminal angles. So I don't really care about the reference angle, though I could go back and do the same. But I need now other angles that end in those same locations. So 210. What's another one that ends in that same location? Well, it's not 35 degrees. Or sorry, the 30 degrees that I talked about before. I could now go all the way around and then end there. That would work. Okay, so what's 210 plus 360? That's one full loop, and then another 210 degrees. 0, 7, 5. Okay, 570 degrees. Or I could go the other way, right? What if I went negative until I got to that location? Well, a full circle would be 360. How short am I of that? Well, I could do 210, and I could subtract 360, and I get 150. But remember, it's negative. I went negative 150 degrees because I went clockwise. So both of those, the 570 and the negative 150, are coterminal with 210. They all end at the same location. Now let's do 75. So let's do my negative angle first. If I go around the other direction, how many do I need to go? Well, it's 360 minus 75. Got to borrow a bunch, right? This now becomes a 35 and a 10. 5. What's that? Oh, 28. So 285 degrees. But remember which direction I was traveling, so this is now negative. And I can take my 75 and I can add 360 to it. 435 degrees. Both of those get me the same as a 75 degree angle. They end in the same location. Now I have 315. Well, this one's nicer, right? Let's find this little missing gap here. That one's going to be a 45 degree angle. Negative though, because again I went clockwise. And then if I went all the way around this circle, right? If I went all the way around, then I did 315 degrees. How much is that? Well, 360 plus 315, and that gets me 675. So both of those are coterminal. I should always be able to come up with a negative and a positive angle that all end at that same spot, that same terminal side. Let's keep going. So for here, I want to give a possible positive and negative angle for each reference angle. So they gave me two pieces of information. Told me the angle and what quadrant it's in, because that's important. So 10 degrees in quadrant 3. Well, where's quadrant 3? This is 1, 2, 3, and 4. So I'm down here in this. Don't care about any of that. It's not there. I'm only looking at that little chunk. And it's a 10 degree angle there, so it's pretty shallow. And you have to remember my reference angle is this chunk in here, right? That's the 10 degree, right there. That's the part I care about. So what angle then gets me all the way around to that location? Well, 180 plus 10 degrees more. So this one could be 190 degrees. But I also need to give a negative. So what happens if I come down to that location? So I'm 10 degrees short of 180. Well, that's 170. But remember the direction you traveled. That's a negative. All right, next one. 35 degrees in quadrant 2. So I know I'm in this quadrant over here. And it's a 35 degree angle. So that 35 degree angle comes from my nearest x-axis and then my line. And I don't ever care if your pictures are perfect. I mean, if you draw a 35 degree angle, it should probably be somewhere in the middle, but this is probably closer to 45. I don't really care. As long as your numbers are good, we're fine. So 35 degree angle, I'm in quadrant 2. Good. Now, what's a positive angle that'll get me all the way to that? Well, all the way over to my x-axis, all the way over to x-axis, 180, I'm 35 degrees short of that. So it's 180 minus 35. That's 145 degrees. Then I also have the option of going negative up to that location. So this is 180, right? 90 to here, 90 again to here, so I'm up to 180 plus 35 more degrees. And that is 215. But remember the direction I traveled makes that negative angle. 22 in quadrant 4. That's going to be over here, right? Connect my line to my nearest x-axis. This is a 22 degree reference angle. My reference angle is always to my nearest x-axis. I am on the correct quadrant. Good. So this is actually a negative 22, gets me there, or a positive, how much? 360 minus 22, 340, 338, a 338 if I go positively. Nice. So all of these locations, I gave a positive and a negative for each of those reference angles. Awesome. Let's keep going, folks. You know what? That's actually everything. I appreciate you watching. My next video is going to be more about the unit circle. We'll get a little bit more broad, and we'll do way more cool things. I hope all of you continue to do things carefully and with enthusiasm. Have a great rest of your day. Make sure you subscribe and hit that little bell if you want to get notifications about my new videos. Goodbye, everybody.